फ्रेंड्स, हाय दोस्तों। आज हम पढ़ने वाले हैं रिफ्रैक्शन ऑफ लाइट फेनोमेना एट अ प्लेन बाउंड्री बिटवीन द टू मीडिया ऑफ द 12th फिजिक्स स्टेट बोर्ड पैटर्न, महाराष्ट्र स्टेट बोर्ड पैटर्न। ये रिफ्रैक्शन ऑफ लाइट देखने से पहले अगर आपको ये वीडियो पसंद आ गया तो बहुत ज़्यादा उसको सब्सक्राइब कीजिएगा, उसको लाइक कीजिएगा और बेल आइकॉन दबाइएगा, क्योंकि आपको ये वीडियो जब मैं अगला वीडियो डाल दूँ तो आपको भी वो मिल जाए। चलो, लेट अस कंसिडर रिफ्रैक्शन ऑफ लाइट एट ए प्लेन बाउंड्री बिटवीन द टू मीडियम। इट मीन्स दैट वी हैव टू प्रूव हियर द लॉज ऑफ रिफ्रैक्शन ऑफ लाइट ऑफ अ plane wavefront, then that plane wavefront is incident on the boundary between the two media. Now here, first of all, we shall consider Mn. It is a plane boundary which separates one medium into the two medium. Here we shall consider the medium number 1 or rarer medium, another medium, that is medium number 2. It is also called as the tensor medium. Now in medium number 1, the velocity of light is v1, and in medium number 2 the velocity of light is v2. Now here we shall consider a plane wavefront which is the AB. It is called as the incident wavefront, which is bounded by the two parallel rays A dash A and B dash B, or A dash A and B dash C, which is obliquely. It means that it makes some angle with the plane refracted wavefront, that is Mn. Now this plane wavefront AB will gradually moves as the time passes towards the plane refracted surface Mn. Now this plane wavefront AB, which is called as the incident wavefront, will touch this surface Mn at the point A when the time t is equal to 0. जब ये plane wavefront यहाँ पर टच होगी किधर, at point A to the surface Mn at time t is equal to 0, then according to the Huygens principle, this point A is acts as the source of secondary disturbance which emits the secondary waves, that is the secondary wavelets in all possible direction. It means that this point A, which acts as the source of secondary waves, will emit the secondary waves in the second medium, that is in the medium number 2. Now meanwhile, the point B of the plane wavefront, incident wavefront AB, which is at B, will touch the Mn refracting surface at the point C in time t. And then this distance BC, it is equal to v1t, because v1, it is the speed of light in the first medium, and time t, this is the time t during which the point B touches the point C. Now during this time t, the secondary waves starting from point A, which acts as the source of secondary disturbance, will emit the light, that is the secondary waves, in the second medium of the distance v2t, where v2, it is the speed or the velocity of light in the second medium. Now this v2t is less than v1t, because v1, it is the speed of light in the first medium, and v2, it is the speed of light in the second medium. The value of v1 must be greater than the value of v2. Here we shall consider the first medium, it is the rarer medium, and second medium, it is the denser medium. Now this v1t is greater than v2t. Now meanwhile, in between the time t it is equal to 0, when that plane wavefront, incident wavefront, touches at the point A, and the point B of the plane wavefront, incident wavefront, touches the point C at time capital T. In between these two times, the secondary waves starting from point A will reach the distance v2t, and the incident wavefront AB, its points are touched to the surface Mn. As soon as these points are successively touched to the surface Mn, which starts to emit the secondary waves in the second medium having the radius in between V2T to 0 A and C. Therefore here we can draw the hemisphere of the distance V2T. Now this one, it is the hemisphere we can draw, and other sources of light in between the points A and C will emit the hemisphere having the radius less than V2T in between the points A and C. The secondary waves of the plane incident wavefront, when it touches to the surface Mn, then it will emit the light waves having the radius in between V2T and to the 0. When the point B touches the point C, then the hemisphere emitted by the point C in the second medium, it is equal to 0. Therefore radius here, the radius is equal to 0. Now if you can join this CE, now this CE will represent the tangent drawn to the all the hemisphere which emitted in between the points A and C. Therefore this CE will give the refracted wavefront in the second medium. CE will give the refracted wavefront in the second medium. Now here we cannot draw a normal. Now at the point A to the surface Mn, normal बोले तो 90 डिग्री का एंगल करने वाली एक रेखा यहाँ पर हमने ड्रॉ किया, उसको नाम दिया ए डैश उसको नाम दिया। तो ये ए डैश ए जो है ये क्या एक्ट होगा, ये जो एक्ट होगा ये इंसिडेंट रे है, ये जो है नॉर्मल इंसिडेंट रे, और नॉर्मल इन बीच में का जो एंगल है उसको हम कहेंगे एंगल ऑफ इंसिडेंस। नाउ फ्रॉम दिस ज्योमेट्री ऑफ फिगर, this angle, that is the angle of incidence A dash AP. Now this angle, it is equal to BAC, it is equal to I, it is called as the angle of incidence. Now here in the second medium, this is the refracted ray, AE it is the refracted ray, and this one it is the normal. Now the angle made by the refracted ray with the normal, it is called as the angle of refraction. Therefore this angle EAP dash or P dash AE, it is equal to R. Now from again the geometry of figure, here you can write this angle, it is equal to ACE or ECA. Therefore here you can write P dash AE, this angle, it is equal to angle ACE, it is equal to angle R, it is called as the angle of refraction. Now here we shall consider the two triangles. Now this one again it is the right angle triangle, this one again it is the right angle triangle. Here we shall consider a right angle triangle ABC. From this right angle triangle, here we can write sin I, the value of sin I, it is equal to front side, that is the BC divided by hypotenuse, that is the AC. Now this distance BC is equal to V1T. Therefore here you can write from triangle ABC sin I, it is equal to BC divided by AC, it is equal to V1T divided by AC. What is equation number 1? Again from the second right angle triangle which is inside the medium number 2, here we can write this triangle is ACE. From triangle ACE we can write the sin R value, this is the R angle R. Therefore sin R, it is equal to front side, that is AE divided by this hypotenuse, that is the AC. Now this AE, it is equal to V2T. Therefore here you can write AE divided by AC, it is equal to V2T divided by AC. What is equation number 2? Now dividing these two equations, dividing equation 1 and 2, here you can write sin I divided by sin R, it is equal to V1T divided by AC whole divided by V2T divided by AC. Now this AC will get cancelled out, TT will get cancelled out, therefore remaining term is it is equal to V1 divided by V2, it is equal to, now here we can introduce the velocity of light, that is the C. If you can introduce the velocity of light, that is the C, it is equal to this one it is the C divided by V2. Here you can write C divided by V2 whole divided by C divided by V1. This term, here we can introduce the value of C, then the CC will get cancelled, again we can get the original term, that is V1 divided by V2. Now C, it is the velocity of light, which one it is the constant in the first medium, and its value is it is equal to C, it is equal to 3 into 10 to the power of 8 meter per second. Now this quantity it is called as the N2, it is called as the absolute refractive index of the second medium divided by N1, it is the absolute refractive index of the first medium. We can cross multiply this one. Here we can write, therefore N1 sin I, it is equal to N2 sin R. Now this law that we have considered in the 11th standard, which one? It is called as the Snell's law. The first point in the laws of refraction is that here we can prove the Snell's law. अगर हमें यहाँ पर रिफ्रैक्शन प्रूव करना है तो उसका फर्स्ट पॉइंट है यहाँ पर स्नेल्स लॉ प्रूव होना चाहिए. तो यहाँ पर हमने स्नेल्स लॉ जो है ये प्रूव कर दिया है. ये जो है फर्स्ट पॉइंट है लॉज ऑफ रिफ्रैक्शन. सेकंड पॉइंट जो है, नाउ दिस वन इट इज कॉल्ड एज द incident ray, this one it is called as the refracted ray, and this one it is called as the normal. Now this incident ray and the refracted ray both are lies on the opposite sides of the normal. This is the second point in the laws of refraction. Third point is that, now this one it is the incident ray, this one it is the normal, and this one it is the refracted ray. All these are lies in the same plane. ये तीनों भी हैं, ये एक प्लेन में है. इन दिस वे वी कैन प्रूव द लॉज ऑफ रिफ्रैक्शन ऑफ लाइट ऑन द बेसिस ऑफ हाइजेंस वेव थ्योरी ऑफ लाइट. हाइजेंस वेव थ्योरी का आधार लेकर हमने यहाँ पर रिफ्रैक्शन ऑफ लाइट जो है यहाँ पर हमने प्रूव कर दिया. नाउ नेक्स्ट पॉइंट, इफ v1 इट इज द स्पीड ऑफ लाइट इन द फर्स्ट मीडियम, हियर वी शैल कंसीडर द फर्स्ट मीडियम इट इज द रेयर मीडियम एंड सेकंड मीडियम इट इज द डेंसर मीडियम. देन ऑब्वियसली वी नो दैट हाइजेंस ने कहा है, क्या कहा है, द वेलोसिटी ऑफ लाइट इन द रेयर मीडियम is greater than the velocity of light in the denser medium. It means that the v1 is greater than v2. It means that if v1 is greater than v2, then we can write that is n2 is greater than n1. N2 is greater than n1. That is, here we can write n1 is less than n2. N1 is less than n2. It means that I is greater than R. Angle of incidence is greater than angle of refraction. It means that from this we can conclude that if the light travels from optically rarer medium to the optically denser medium, then the refracted ray is bent towards the normal. That is, the refracted ray is bent towards the normal. On the other hand, if the light travels in the reverse direction, that is, if the light travels from optically denser medium to the optically rarer medium, then the refracted ray is moves away from the normal. Then the refracted ray is moves away from the normal. Now second point is that here we cannot get the inverted image as we can see in the reflection of light. यहाँ पर हमें inverted image नहीं मिलती जो कि रिफ्लेक्शन ऑफ लाइट में हमें मिल रही थी. इस तरह हमने हाइजेंस वेव थ्योरी का आधार बनाकर लॉज ऑफ रिफ्रैक्शन जो है इन द केस ऑफ प्लेन वेव फ्रंट विच इज इंसिडेंट ऑन द बाउंड्री बिटवीन टू मीडिया विल बी प्रूव्ड, वो हमने प्रूव कर दिया है. थैंक यू.